We paste the question here. So the question is reading, given the demand function equals P equals 200 minus 5Q, express the total revenue function as a function of Q given. Now, this P represents price. Then remember, colleagues, total revenue is price times quantity. Okay, so TR, total revenue, is price times quantity. So in this question here, P is going to be 200 minus 5Q. So we expand Q times 200, we get 200Q. Q times negative 5, you get negative 5Q squared. So this is our total revenue function, 200Q minus 5Q squared. Any questions? At least these ones for total revenue functions, they are consumer friendly. Any questions? Okay, next is the marginal revenue. Okay, so the marginal revenue is the derivative of the total revenue. Okay, so marginal revenue equals the derivative of the total revenue function with respect to x. So we're deriving the total revenue function with respect to x. So colleagues, those who remember differentiation, when we derive this function, what do we get? Yes, this is to q to the power 1. So when we're deriving exponent times coefficient, 1 times 200, that is 200. Subtract a 1 from the exponent, 1 minus 1, that is 0. So q to the power 0 is the same as 1. Then here, this 2 multiplied by negative 5, that's negative 10. Subtract a 1 from there. So 200 minus 10Q. Okay, so this is our marginal revenue function. Okay. Yes. Any questions? Or on this part here, this DTR, or what we're saying here is when we derive this total revenue function, the variable, the letter that we're going to be focusing is with Q. That's what it's saying. Okay. Yes. That's why when you're doing partial differentiation, if you remember in our, was it with you guys? What I did? If you remember in partial differentiation, On the denominator, whatever letter is there is what you're going to be differentiating on the equation. And if no number has got that letter, it disappears. So this what is just saying, we're deriving our total revenue function with respect to Q. Meaning for our total revenue function, the variable that we're going to be focusing on is the Q variable. That is what we're going to use to um, differentiate. Then marginal revenue. Colleagues, what does marginal revenue mean? Yes, when you sell one extra good, it's the additional revenue that you get when you sell one more good. Okay. Yes. So is that okay, Mr. Fumbeshi? Um, the concept. Okay. Yeah. They conjugate. No, mm, that's the that's the marginal revenue according to mathematics and economics is the first derivative of the total revenue. So when you want to get your marginal revenue, you need to derive your total revenue. That's why I did the total revenue. Uh, and if they say find the marginal cost, it means you have to derive what total cost. Mm, mm, mm. Mhm. Let me just interject. Yes, yes. What's happening? Okay. Think of this as this is the rate of change of total revenue. Think of it like that also. Okay. It's the rate of change of total revenue. Okay. And there's another thing I need to mention. Remember, the profit maximization principle is for a firm to maximize profit, it has to produce a number of goods where the marginal cost equals marginal revenue. So please remember, this is a profit maximizing condition. So it might not come in maths, but you might see it in economics. Because most market structures they will follow this. They also follow this principle. When marginal cost, when the additional cost to produce a good equals the additional revenue to sell the good, That's where you maximize profit. Okay, so please remember this point here also. Yeah. So usually these questions are set up in this structure, colleagues. As I said, the formula, just remember this one: total revenue equals price times quantity. All right. Total cost, number of units times the cost per unit. Number of units times this is total cost, yeah. Number of units times the cost per unit. Okay, because with these questions, if you forget this formula, you will form the wrong functions. Okay. So once you get your total cost and your total revenue, and always remember Q is always going to be your variable of interest. Okay. So once you get total revenue and total cost, then when you derive both, that's how you can get. If you derive total cost, you get marginal cost. If you derive total revenue, you get marginal revenue. And when you equate these two, you find out how much you need to produce to maximize your profit. Okay. When you equate these two, it will give you the number of units you need to produce so that you maximize your profit. So it's a profit maximizing condition. Excuse me. Yes. Part C, find the value of Q when total revenue is zero. So if you notice, our total revenue function is a quadratic equation. Okay. It is 200 Q minus 5Q squared equals 0. Okay, this is a quadratic function. Okay. So colleagues, how do we solve this first? Yes. Mm-hmm. 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 You are okay there, yes, sir. Okay, remember, colleagues, if you have a quadratic equation where there's the squared and just the power one, this is what you usually do. Factorize. Okay, then when you factorize, you use the zero product rule. And the zero product rule is this one where you say, okay, Q equals 0 or Q equals, oh, you say 200 minus 5Q equals 0. Okay. If you remember in the questions for logarithms, also we did the similar thing with like this. Okay. This is the zero product rule. So 200 minus 5Q equals 0. Okay. Then you solve for Q. You take negative 5Q over the equal sign. Divide both sides by 5. 200 divided by 5, that is 40 units. Okay. So when you make 0 units, your total revenue will be zero. If you make 40 units, your total revenue will also be zero. Okay. Any questions before we move further? Mm-hmm. Oh yeah, you can also do that, sir. You can also do that. Okay. You still get the same answer. Okay. So if we factorize, you save common element is 5q, right? So 200q divided by 5q, that is 40, minus 5q squared divided by 5q, that is q. Okay, then equals 0. So then you say 5q equals 0, or 40 minus q equals 0. Okay. So here 40 minus q, you still get 40 units. Here where 5q equals 0, if you divide both sides by 5, 0 divided by 5 is still 0. Okay. So you still get the same answer. But thank you for that, sir. Okay. Yes. All right. Yeah. So basically, if you produce 0 units, your total revenue will be 0. And if you produce 40 units, your total revenue will be 0. Okay. The next part is saying graph the total revenue function in A and use the graph to find the maximum total revenue. Okay. So colleagues, this total revenue graph is a quadratic equation. Okay. So it's also got a quadratic graph. Okay. So whenever you solve a quadratic equation, when they tell you x equals this, x equals that, those values are basically your x-intercepts. Okay. So here, when we solved here this quadratic equation, we got q equals 0, q equals 40. So at this point here, 0, and this point 40 here, that's where this quadratic equation is going to be cutting the x-axis. Okay. Next, you have to look at the sign for the coefficient of the q squared. Okay. If it's a positive sign, your quadratic equation is a small. Okay. If you have a positive sign in front of your x squared or your q squared, then your quadratic equation is a small, meaning it has a minimum. Now, if then it's negative, the coefficient of q squared, it means you have an upside down smile. You have a frown. Okay. And this is your maximum value. So this graph going to be like this. But we need to find what this point is here. We need to find the coordinates for this point here. Okay. We need to get the coordinates for the top point here. Okay. And how we get the coordinates? Okay. To get your x coordinate for the maximum value for a quadratic equation, it's this x equals negative b over 2a. Okay. Our quadratic equation here, it's 200 q minus 5q squared. So negative 5 is our a, 200 is our b. So you're going to say negative 200, since it's negative b, so you say negative 200 over 2 times a. A is negative 5. So negative 200 over 2 times negative 5, that is negative 10. So negative 200 divided by negative 10, that is 20. So in this context, our x is also q, okay? Because on our x-axis is quantity here, on our y-axis is total revenue here. Okay. So when we sell 20 units, we'll make our maximum revenue. And we need to find out what will be our maximum revenue. Okay, we want to find out what will be the maximum revenue with these 20 units. So you just substitute q equals 20 into this function here to get your total revenue. Okay. So 200 q, so q substituted with 20, minus 5 times 20 squared. So 200 times 20, 4,000. Minus 20 squared is 400 times 5, that is 2,000. So 4,000 minus 2,000, that gives us 2,000. Watch. So here on your graph here, on this total revenue, it's 2,000 here. Okay. So when you produce 20 units, you're going to make the maximum total revenue of 2,000 kwacha. Yes. Any questions?